All right, I have a Middleby Marshall Conveyor Oven that is not heating. All right, so we do have a call for heat here from the board, set to 452 degrees. So let's see what's going on. Pretty tight area to work in today, but that's all right, we'll get it done. So let's peek in here, see what's going on, and we're at full burn, so it means we have an intermittent problem. So let's sit back, relax, and wait for the unit to fail on us. So we're about the 25-minute mark. You can see here we're not quite flashing a code. It's almost like we're dropping voltage. So this thing will flash either 1, 2, or 3 flashes. So let me just go check the wiring here and make sure everything's good and tight. And we'll take some voltage readings after we go study our schematic for a little bit. So let's go pull up a schematic and get a game plan going. Alright, so we got our schematic here. Let's blow this guy up. So first thing we're going to do, like always, let's go find our load. So in this case, we're getting some funny lights flashing at the module. It almost feels like we're dropping voltage and we're not dropping voltage. So let's go ahead, let's find this ignition module. So ignition module's right here. Okay, so I have 2 test points here. I can test either here at TH and ground. As you could see in the previous clip, I couldn't get my meter in there. So let's come right here and we're going to test from right here. Okay, so what this is going to tell us is, are we getting correct voltage coming off of this transformer? Okay, is the transformer dropping voltage? And if it's not dropping voltage and we're getting correct voltage the entire time, so if we're getting our 24 volts to this module the entire time, that's telling me this module's bad. So let's go take some readings and see what happens. So we're getting 23, 10, 0 volts. Alright, so we're getting crazy voltage here. 24, 0, 12. So that's why the light keeps going crazy on this module. That's why it's going on and off, on and off, on and off. We're dropping voltage, okay? So the next point we're going to check here, we're just going to come check our incoming power to this transformer. Okay, and if we start getting funny voltage from here, we'll just keep working backwards in the schematic. Alright, so we are getting 140 volts, 136. It's just fluctuating like crazy here. So let's go back and see what's going on in the schematic. Alright, so let's just follow our circuit here. So our one line is coming off of here, which is kind of feeding the entire circuit. So this is kind of our main power in if we keep following it all the way around. And we'll draw as far back as we need to here. And this is coming off of here. So basically this is probably going to end up going into, wow, into our main power. Struggling. And this is coming all the way back to right here. And you can see it's labeled L2. So there's our one line. We know this line's constant. We're probably not going to be dropping voltage on this line. Okay. So let's follow our L2 line, which we're going to draw in blue. So one of them is piggyback right off of this transformer. So I don't think we're going to be dropping voltage through there. And then we're coming through here through this heat switch, which potentially we could be dropping some voltage. And then we're coming through this relay. So we're coming up through this terminal 8, okay? So it's a normally closed on 7. When we get power to the coil, it's closing on pin 6 on the relay. Pin 6 is coming up through here, and it is coming through an air switch. So what this is our pressure switch, okay? So this pressure switch just wants to make sure that both of our motors are running. So we have 2 blower motors here. They both need to be running in order for this pressure switch to close. So what's making the most sense right now is this pressure switch is probably opening and closing. Something might be going on with the switch, or maybe the tubing's bad, or one of the motors are bad. But let's go investigate right here this switch. Okay, so we're going to test power in at common. And then we're going to test across the switch, and we're going to test for potential difference. Alright, so we have 122 volts across the switch. So across this air switch, from common to normally open, we're getting 122 volts. So what's that telling us? This switch is open, okay? We're testing for potential difference. If we had 0 volts across, that means the switch is closed. We're completing our circuit and we're gonna get good voltage going up to our transformer through our relay, okay? Because we're getting 122, that means this switch is open. Okay, so the first thing I'm gonna go do is see what kind of negative pressure we're getting coming into this pressure switch. Alright, so you can see our pressures are fluctuating. 0.20, so I think you need 0.08 to close this switch. So that's why it's opening, closing. So we do not have the proper pressure coming back to the pressure switch. So the pressure switch is doing its job. So let's check out this motor. And this right hand motor here is completely seized. I tried moving with a screwdriver, it is not budging. And if we continue to investigate here, you see the tubing is rotted. So even if the motor was working, we'd be dropping voltage as well. Last thing we want to do is make sure we have power at the motor. We have 208, we have good power, we're all good. All right, so our right hand blower motor is not running. There is a capacitor, but because I can't even move the screwdriver, this motor's done. Okay, so let's just draw out our circuit really quickly. So we know we're getting full power to these blower motors. And then as you saw, that tubing that it senses the air pressure on is completely rotted. So I think maybe what was happening was that tubing rotted out and that thing's been short cycling forever on that pressure switch. Okay, so we're gonna need a blower motor and we're gonna have to change all that tubing as well. Alright, so let's go ahead and get this right hand motor replaced. So this whole kind of back panel drops off. And then the center portion comes right out where you see that tubing there. And then rip out a bunch of insulation out of here. And the insulation's probably going to crumble on you, so it's a little bit of a pain to pack it back in, but I think the oven's pretty old, not much you can do about that. And once you get that insulation out, there'll be 2 nuts holding the whole assembly out. And then the whole motor is just going to pull right out towards you. The good thing about this motor is it comes complete with the blower wheel, so you don't got to worry about popping off a blower wheel or anything like that. Alright, we're just going to pop back in our tubing here. That tubing was still good. That clear tubing. So we're going to go ahead and test across this pressure switch. Okay, we're getting 0 volts potential difference. So that tells us the switch is closing as it should be now. Alright, so we just tested our potential difference, which is across common and normally open, and we were getting 0 volts. So what does that tell us? It tells us this circuit's closed. So our common's coming from here. It's closing this circuit right here, which means we are now going to get power, good power off of 6 of 8, which is going to be a straight shot here, and we're going to get constant voltage now to our transformer, which means we're going to get constant voltage to our module. And that issue is resolved, so now it's time to fire up the oven, make sure it gets the temperature, and let's see what happens. So just before the unit got to temp, the module locked out again. So that's telling me we're probably having an issue with the low fire. So this unit has a high fire and a low fire. So first thing I'm going to do is go ahead and adjust the high fire pressure. So it's set to 4 inches. I want it down to 3.5 or as close as I can get to that. And we got it pretty stable here, 3.5, 3.6. I'm pretty happy with this. So the next thing we're going to do is we're going to test the low fire. So in order to do that, I'm going to pull the wire off of the modulator for the gas valve. And as you can see, we're going into actually a negative pressure here. So I'm going to bump up the low pressure. So what you do is you put a wrench on the nut for the high fire. So it's just like a backer wrench, and we're going to crank it up. All right, so I'm going to unplug this wire again to go into low fire. So we're getting about 1 inches water column on low fire, which is a little bit too high, but at least now I can adjust it because I have a flame there. We're not going into lockout. You want to be about 0.5, 0.6 inches water column, as close as we can get. We're at about 0.56, 0.57 inches water column. So that means we're good on low fire. And we'll just show a visual here. The low fire is running. If I can get the camera a good angle in here so you can kind of see there. That's the low fire, okay? And I'm just going to plug the wire back in. I'm going to show you high fire just so you can see the difference, but you can hear it. But you can see that. Look at that. So we went from 0.5 to 3.5 inches water column. High fire and low fire are now working, and the unit is cycling as it should be. Quickly go into high fire and low fire. So the whole reason why we have a high fire and low fire is, so if we're set to 450, so let's say around 445, somewhere there, we're going to go into low fire. So we're not going to overshoot the temperature. And as long as we're in low fire, we're not going to get over our set point. Okay, we're not going to get up above 452. And then once we drop a couple degrees below, so that low fire is no longer maintaining temperature, the high fire will kick back on. Okay, so the whole point of that is so we don't overshoot the temperature. Okay, we have good steady heat. So usually these are used for conveyor ovens. For this place, it's for seafood and stuff like that. But usually for pizzas, you want constant temperature. You don't want to set it to 450 and then the thermostat shuts off at 450, but it goes to 475. So that's why we have a low fire. So all the low fire really is first of all, we bring power onto here to our gas valve. Okay. So the gas valve has power. Anytime we have power on right here on the modulating valve, we're on low fire. Okay. So we have power on these guys right here. We're on low fire. So that's why you saw me in the testing when I took power off of these. So you can remove wire 400 or 41, it doesn't matter. Once we no longer have power on these terminals right here, we go to high fire. Okay, so the easy way to test it is pull the wire off and then the valve is fully open. When there is power at that modulating valve, it closes it down to, as you saw, I adjusted it to 0.5 inches water column. So pretty interesting oven we have here, this conveyor oven. It's got the low fire and the high fire. Pretty cool technology. So as you can see, we don't want the temperature to overshoot. So before we get to set point, we go down to low fire to maintain. And then once the temperature drops below that maintain temperature, we go back to high fire. So we had a bad motor there. We had the tubing was bad as well. So we had a lot of issues. It's super important that you test it to the set point, okay? So I was probably around 445. I started packing up all my tools. I'm like, we're good. And then I seen the temperature didn't really get to 452. And then it started dropping. And then the high fire would turn back on. So I knew right away there's a problem with the low fire. So it's really important that you test things to the set point. Now, there's not many units on the hot side that use this kind of technology of low fire and high fire. The only thing I've really seen it on is all these conveyor ovens. So XLT will have this same kind of technology with high fire and low fire. And then I've seen it as well on the Cleveland steamers. So during ignition, you'll be on low fire and then you'll bump up to high fire. But they don't use it to maintain a specific temperature like we're using on this. So it's always cool to see new technology, new ways of engineering things on the hot side and the gas side.